use. So same thing can actually be, done in other softwares, designing software such as your SolidWorks, CATIA, okay, NXCAD. So these are very primarily used design softwares in the industries. Okay, so if you want to kind of pursue designing or any type, even simulation, so your first basic will always be start with design. Okay, so that is what we are going to see, right? Uh, so before moving on with the software, okay, so you should first understand what is from the design perspective. Okay, uh, you should understand as to, okay, if you take an automobile bonnet, right, so what does it like complies of? Okay, so it has to comply to some certain regulations, right? So there are few design attributes that you have to follow before designing, because without that you will not be making a good product, okay, for the market. So I have a small presentation. So I'm just going to share my screen. Okay, so we can go through the presentation before we move on with the design, right? Okay. So hope my screen is visible, right? So
Yes,
as you
yes.
can see, yes, thank you. So as you can see that we are talking about automotive design, bonnet design, right? So when it comes to automobile, bonnet design, what people usually see is the design, right? Because that basically becomes a fascia of an automobile. Okay. The lights and the structure, the moment a person sees a vehicle, okay, from the front, so it becomes a first impression. Okay. But apart from the aesthetic changes or the aesthetic looks of it, okay, a bonnet has to do more than what it is just, projecting, right? Design is a very crucial part of it, yes, but it should also contribute to the uh, you know mechanical design of it, right? So that is what we are going to see. Okay, so so when you take a bonnet, right? So what is it that you know makes it sturdy, rigid?
Saswin sir, can you just give me a minute? Just a minute.
Sure.
Like students, I would like to request you not to put all these lines and all on the screen when sir is sharing actually, because it will be difficult for other people to understand. It's a kind request to everyone not to put any sort of lines or anything on the screen. And whoever is doing it, can you please remove it? It's actually better because we are here in an informative workshop, and these things are least expected from you people. You can continue, sir.
Yes, thank you. Yeah, so coming back. So basically, first thing that you should see is the structure, right? Uh, so when you start designing it, okay, be it a hatchback or be it a SUV, right? Even sedan, right? So everything has a particular structure to it. Okay, you cannot just design uh, a bonnet or maybe the hood, right? So it cannot be designed for different type of category or different type of a vehicle. If you cannot take an MPV bonnet and put it in a hatchback, right? So the first thing that comes is your structure, the structure and function of it, right? So that basically involves your design attributes. Then after that, once you have the shape, right? Once you have the initial sketchings, then you go on to design considerations. Okay. So what are design consideration is your manufacturing capability. Okay. And then because under the hood, you're going to have your engine or maybe your EV cooling system, right? So all that. So it has to cater to that. So you have certain design regulations that needs to be followed. And so those will come into play. Then after that, once you have the, design, right? So then you go on to the engineering principle. So what does mean by engineering principle is nothing but your, again, so manufacturability. At the same time, your thermal properties. Okay, because it has to withstand aerodynamic forces, it has to withstand thermal forces, right? And it also has other, pedestrian safety and all those stuff. Okay, so these are the three major consideration that you should take while starting to design a product. Okay, so let me just give me a minute. I'll just change to the next slide. Yeah. So, talking about external forces, right? So, the external forces are first thing that you have to see is because a vehicle is basically moving front, right? So, it has to basically cut the air in front. Okay. The faster the air gets, away from the vehicle's path, okay, the faster the vehicle can move forward, right? So, that's a resisting force. So, when you're basically, designing a hood, so it has to be aerodynamic, okay, in nature. So that is like optimizing your design. Okay. So if you see a normal passenger vehicle, they have a certain limit or certain degree of aerodynamic, and it varies. If you take the high performance cars, there you have a complete aerodynamic makeover, right? So why that is for reducing your drag, okay, and by reducing your drag, you have to optimize your airflow, okay, and if you achieve this, then obviously you're going to get a better aerodynamic stability. Okay, and final end goal of it is that your car is basically going to, go faster. Okay, it can do a quarter mile in certain seconds, right? Okay, so now you know that these are the external forces, right? Then after that, after the forces, you have other, considerations to take. That is your safety concerns. Okay, because a person, it can be any type of safety, right? So it can be pedestrian safety, it can be, vehicle, if by chance, right, if there is a frontal impact. Okay, so the forces has to be absorbed by the hood bonnet itself before traveling, before, the force is being traveled to the chassis, right? Your A pillar. Okay. If you can see from the picture that is here, right? So this is your front hood, and if you have a frontal crash, okay, frontal impact. So what happens is you must have often seen that the bonnet basically crumples, right? It basically gets crushed first before reaching the you can see the before reaching your windscreen, right? So that is the engineering that goes into the bonnet design. Okay, so that basically nothing but your impact absorption, and then followed by, so that basically gives a pedestrian safety. Okay, it's because when you're going, right, so it can be a person who might get injured by just by hitting. So it basically has to be rigid, at the same time it has to be a little bit flexible. So if you put a hand on top of your bonnet and press it, okay, with one hand, it basically goes down, right? It feels like as if it's not that sturdy. So that is the engineering behind that, is just so that if a person, okay, or any living object or something that hits that one, so before the force is being absorbed by the bonnet itself, okay, so that it doesn't hurt the person much. Okay, and then after that, once you have that, then you come on to material selection. So all this, finally it comes down to material, right? You cannot have a solid steel, okay, that will basically might give you a good stability, strength to the part, but it's not as flexible, right? You cannot basically create what do you say, absorption force on solid steel. So you have to select material according to your vehicle budget or the category, and at the same time it has to be some alloy type of metal. Okay, so all this has to be taken into consideration while designing. So these are certain materials that are quite widely used in automotive sectors, from steel to aluminum, and basically they use alloy of aluminum. Okay, and carbon fibers used for extensively for your race machines. Okay, for racing purposes, because it has to be very light, and because there, if the prod like if the if you have a crash, or if you basically if the part gets damaged, so carbon fiber is very it's very light, but at the same it's not very reusable. That's one limitation. Okay, basically if it breaks, it just breaks, you cannot repair it, you just have to throw it. Okay, uh, unlike our passenger cars, right, you basically you have your part. If you have a dent or something like that, you can basically give it to the body shop and get it repaired. Okay, there are certain composites, okay, which are not like very widely used. It's very customized type of composites. So that those are the, if you want to create a wing, okay, or if you want to create a spoiler or something like that, so a small part that contributes to a certain uh, you know department, right? It can either cater to your aerodynamic, or it can cater to your weightlifting. So those type of small parts are basically made out of composites. Okay. So these are your materials that you often see in the markets, both domestic and internationally, right? Okay. So now we have talked about materials, and we'll just little bit touch upon styling and aesthetics, because that, again, I have told you that the initially starting, right? So anyone who sees the vehicle basically, you know it's a cliche to say that, but that is what happens. Basically, they just by looking at it, they get a first impression and they judge the vehicle, saying that it's whether does it look good or doesn't. It's not good compared to the other competitor in the market. Okay, so when you're designing it, it has to follow the design aspect. Okay, it has to align with the brand identity. Okay, because if you see, imagine you take a German car, okay, and you take a Japanese car, right? So the design philosophy differs. That is reflected in your design, right? Or you take an Italian car, right? So the completely you have, just by looking at it, you know that the vehicle is from this market, right? So these are the few styling aspects. Okay. Okay, then under the hood, that's also important. Okay, so under the hood is basically you have your engine, or you have your EV. If you're talking about EV, you have your cooling systems for EVs, right? So all that basically your hood has to withstand that type of cooling. Okay, it should not basically, just because you are running your car for say 12 hours straight, 10 hours straight, and it's screaming at like say 6,000 rpm or something. Okay, and because of the heat, basically your hood should not fail, just because you might have a V8 engine. Okay, and that should not basically spoil the hood or something. So that type of heat should also be with it has to withstand. Okay, not only engine. Okay, the whole bay area that you see in front, right? So everything is basically heat. Okay, we as a passenger, we sit inside an air condition, but the car is not like that, right? The car is basically if the moment you put it on, it basically fires up and it reaches temperatures of 1500, right? So that much of degrees it has to work on. So the hood basically has to withstand all this. So that is what is engine. It has to also cater engine heat dissipation. Okay, heat coming from radiators. Okay, and heat management system is basically, again, it's designed for your EV. Okay, and all. So that is why if you see some of the performance cars, you'll have vents on top of the hood. Okay, that is to cater for this type of cooling system. Okay, right, then little bit of advancements that you see. Okay, because as you can see in the slide here, we just talked about the vents, right? So these are a small aerodynamic and for your cooling vents. Okay, so now coming back, you have like now every time we have talked about various aspects. Okay, so all this, so companies, right? So everyone are trying to optimize their design as as a design engineer or design department is always continuously in process to kind of optimize the design. Okay, whenever they are basically coming out with new models or any type of it varies from from market to market. Okay, so all that basically differs by these aspects, such as it has to be lightweight materials, a little bit of better aerodynamic, okay, cooling systems, and the sensors are being put, okay, like you can see that frontal collision sensor, and you go for cruise control and all this, right? So these are little bit advancements. Okay, so all this, every advancement that goes into a car, okay, the design should also comply with that. Okay, so yeah, uh, so the conclusion is it is a very integral part of a vehicle. Okay, uh, it has to cater with from design to engineering aspect to almost futuristic developments. Okay, so it's a very integral part of a car, the hood. Okay, so we have, so I've basically shown you the introduction as to what that goes into creating it. Okay, so now we will see what is possible in design. Okay, so using NXCAD, I will show you how the design process is, you know, uh, done. Okay, um, I hope the presentation was informative. So just give me a minute, and I will we can continue with the design. Okay, so okay. Uh, yeah, so hope my screen is visible. So we had talked about the designing software, right? So this is our NXCAD. Okay. Uh, so basically, NXCAD is also a designing software. Okay. So unlike you have NXCAD, you have SolidWorks, you have CATIA. So all these three interfaces are used for designing. Okay. So it varies from, it can go from, designing a small part that you see, it can be of any material. Okay. So it is not limited to a certain, material or something. Material comes afterwards. So first the design. Okay. So this is one of the software that is NXCAD, or we can say Siemens. Okay. Siemens is the company that is developing it. Okay. Okay, so let's just so every time when you start, right? So when you start designing, okay, there will be a team before you as a designer who's working on a software. Before you, there will be a team of called creativity engineers. Okay, so what they do is they sit hours in front of just paper and pen. Okay, and maybe some digital paper and pen also. It can that can also be done. So what they do is they basically sketch. Okay, as you can see, they'll have something like a rough sketch, something like this, right? Something as to how to create a car. Okay, something like this. Okay, they'll basically sit and they'll get the layout of the vehicle. Yeah. So once once they have that type of design, okay. So once they have a certain design, something like a bonnet, say I create a bonnet like this, okay, and then they give it a lines, and for aerodynamic purposes, and they give a certain type of vents or something like this. Okay. Uh, so all this, right? So they will finalize the design by paper and pen. Okay. There is no like what do you say? There's no advanced type of method to it. They only stick with initial idea phase is basically it's only on paper and pencil, and maybe like I told you, it can be a digital thing. Okay, so they'll have digital board or something to kind of reflect the design and the shape. So once that design, right? Once that design is finalized, okay, you must have seen sketches. So once that uh, design is finalized, then what happens is then it gets moved on to the design department. So that is where the design engineer work comes. By looking at the sketch, they start creating iterations. Okay, they start creating the part in the CAD model, like the CAD surface that you see here. Okay, so now we are in that phase. Okay, imagine we are now the one that we are going to design. Basically, it has passed. Imagine that it has passed the creativity phase, and we are going to start designing it. Okay, so now this is a 3D space. Okay. This is a 3D space that you see here, right? So you see the axis here. Okay. So what that is, basically you have three planes. Okay. One is your XY, YZ, and ZX. So this is the plane. So what I do is, if I see, you can see that, right? Using the middle mouse button, what I'm doing is I'm just rotating it. Okay. So the 3D space that you see is basically rotating. Okay. Fine. It has 6 degrees of freedom. So for it to rotate. Now again, so now you have to again start with sketch. Okay, though you have the sketch, you to bring it into this 3D space that you see. Okay, you have to start with sketch. So here you have option called sketch. Okay, so you go to sketch. Okay, so once you go to sketch, you basically have to choose a plane. Okay, see, so you basically have to choose a plane because uh, a sketch that you see is basically 2D. It's not 3D, okay? Because it doesn't have any thickness. So it is 2D, two-dimensional. So you have to choose a plane at which you're going to start sketching. So imagine I choose this plane, okay? Imagine the XY plane, right? So choose this. I say, okay. Okay. So now you can see that the sketch has been started. So now you use the lines. Okay, you have certain shapes. Okay, it can be a line, it can be a circle, a square. Okay, so all these are your basic tools for sketching. Okay, so what I'm going to do is I'm just going to create a basic profile. Okay, something like this. Okay, a line, right? Or maybe and then what I'm going to, if you see from the side, right? A bonnet will basically look like this. Okay? It will have a curvature, right? It's going to have a small curvature like this. Fine. So this is how it will be. So this is how you start a sketch. Okay. So okay. So this is how you start a sketch and you basically created a line. Okay. So what I'm going to do, so we have the sketch. Okay. Okay. So I've created a sketch. Okay. Similar to what we just saw using just a line. Okay. Yeah. So similarly, you take a line, okay, and then you can use it. You can use the curve option, okay, arc that you see here, okay, for you to give a curvature profile, okay, and this is how we dimension it. Okay? So basically, the designer, the one who has sketched it, right? They are going to give you a design point of view as to where, like how much of this length has to be. It is 150 here that you can see, right? So you have to follow the same dimension that they have given. Okay, so once you have the sketch, right? So now you have a small idea as to how the bonnet is basically going to look on the side. Okay, so once you have this final sketch, okay, you can see here. Yeah. Just trying to rotate it. Okay. So however you rotate it, it will basically look the same because it's 2D, right? It's just a line. Okay. So then after that, so you have to start creating a sketch. Okay. Because if you see the bonnet, right? So it is not just made out of one single, let's just take this one as an example. Okay, you can see, right? So if you see this, okay, this is not one particular, just one piece. Okay. So when you're designing it, you're basically what you're going to do is you're going to design this part, okay, and then you're going to basically, this is going to be your base that you see, okay, and this one, okay. So these two sheets, okay, what you see here, right? So this is going to be your first layer, and this is going to be your second layer, okay. So and then a layer joining these two. So this is how you get this surface, okay. So the same thing we are going to see, okay. So now you have the base. This forms your base of your bonnet, okay. So once after that, so what you need to do is you have to sketch this, right? So similar to what we have done, okay, you have to start sketching this part here, okay. So you can do the same, right? So again, what you do is you're going to start a sketch again, okay, and then similar using a line and a arc, you're going to draw a just a auto profile of it, okay. So an auto profile will basically look like this. You're not going to make any changes to it. Just a rough profile, okay, based on the sketchings that you get. So once you have this, okay, what you can see here, right? So you have, this is your base, and this is your line that we had drawn. So, right? So now you have two sketches, one your bottom and the this sketch that you see here, right? So this is your the top surface. Now, in order to create a you know part out of it, so what you have to do is you need like in design, what we do is just for easier curvature, right? So what we do is we create another lines like this, similar to this one, what you see, okay, at a distance, so that you get the neat profile along, all along the your base design. Okay. So for that, what we are going to do is there is a option called project curve. Okay. Uh, so what project curve does is now you have the basic sketch, right? You have two sketches as your basic. Okay. Now I just need the same, what you see here. I just need the same, line at a distance. So what I'm going to do is I'm not going to design it once again, right? So there are a lot of shortcuts and, ways to kind of in the software to work around. Okay. As you get familiar with the software, you will be quite confident and time consuming while doing it. So here I just tell you the option. Okay. So here you have something called project curve. Okay. So this is basically a curve. So what you do is you go to curve. Okay. And you have an option called project curve here. Okay. So in project curve, fine. So what you're going to do is you're just going to choose this. Okay, this is the curve that needs to be projected. Okay, and again, coming back, so this is a 3D space, right? So you have to specify a plane, okay, a direction to it. Okay, so I'm just going to use a plane, fine. So I'm just going to use this plane, okay, and I need it. So now you have chosen the plane, you need to show the direction. Okay, so I'm just going to reverse the direction here. And once I say apply, so I'm basically going to get the curve here. Okay. So for easier understanding, so this is basically how you create a curve. There's another way of creating it. Okay. One is you have a datum. So this is basically called as your datum system, datum coordinate system. Okay, which comprises of all your planes. Okay. So I'm just going to recreate the same. Okay, the same datum onto here and another one here. So for me to so that I can easily construct the line again. So for that, what you do is here you have a datum plane. Okay. So similar to what you see here, you can basically create a datum, okay, a datum plane or a datum coordinate system. Okay. If you want just one single plane, you can use this. Or if you want one comprising, you want all the three planes to be there, then you can use datum CSYS. Okay. That's nothing but your datum coordinate system. Okay. So for easier understanding, I'll just create two planes. Okay. you can see here. So let me just so how I've created this is using the same. You go to datum plane. Okay, this is the datum plane. Okay, and you choose this one. Okay, and at a distance. Okay, so you choose this and you create this one at a distance of 30 mm from here, and the same process has been done for the other also. Okay, so you've chosen this and at a distance of 30 mm. Now you have created, this is like a reference point. Okay, now this is like a reference instead of you giving from here. Okay, so if you give it from here, what happens is you're going to give 30 and another one is going to be 60, right? So it's all the same. So whether you create it from 30 and then you create another one 30, okay, it basically depends on the convenience of the designer. Okay, so now I've created two planes, which will be used to sketch my projected curve. Okay, you can also start a sketch. I can go to sketch here and start using use this plane and sketch it once again. But again, uh, thing is, as a designer, you should optimize your design while you're designing it, right? So you don't want to waste your time and creating the same line that you see here by giving again dimensions, and you have to dimension into the thing, right? So that is where we have an option, like I told you, you have something called project curve. Okay, so project curve, go to project curve, right? So this is your curve, right? And then your plane we have already selected. So this is going to be your plane, okay? And a direction is basically going to be this direction. So you see here, right? So I have basically just copied this, profile onto this one. Okay? Now I have this curve. The same thing will be repeated for this one also. Okay? Once I give okay, the same thing is going to get applied. So by using the same, I've created two planes. Okay, like I've created two project curves. Okay, now you have like this is like nothing but just a small guide curve so that you get a even curvature around your design. Okay, so now it's time to create. Now you have the sketch, base sketch, and the curve profile. Now it's time you create the 3D part out of it. So how will you create a 3D part out of it is you have to use a command. Okay, you have to use a command called extrude. Okay, so basically what extrude is, it's an addition of material. Okay, so your 2D becomes 3D, right? So you start giving thickness to it, right? So I've used the extrude command. Okay, again you can select the curve, okay, and the direction. So if you see here, okay, so basically we have used this, okay, this curve here, okay, and the vector is obviously vector means direction. This is your direction, okay, uh, the plane's direction. Okay, so you're going to create it at a length of 170 mm. Okay, basically little outside of this base sketch that we have created. Okay, we don't want it to kind of exactly end over here. Okay, because this is again just a base, right? So yeah, so we have created a sheet out of it, okay, using this curve. Now, what you need to do is you have to again project. Now, this is our, if you see here, this is our basic, profile of the hood. Okay, it has a curve, right? This is our base curve. Once again, I'll just project you the image that you see, right? So this is our, what you see here, right? This one, fine. So we have this area, okay? Now, it's slightly curved, right? So we have that here. Okay. Now what you need to do is you basically need to we have created a sheet at 170 mm, right? You need this type of shape onto this one. So how will you do that? Same as what we did here. So we're just going to copy the sketch. Okay, copy the sketch onto this one. Okay, uh, it's like basically imagine that you are keeping two papers and between you're keeping a carbon paper. Okay, so whatever you write comes onto the other one. right? It's the same. So you're going to use the same sketch here, project it onto this one. Okay. So you have same, you go to curve, you go to project curve, you're going to choose this sketch, and this is your base. Okay. So when you do that, so this is how it will look. Okay. So you go to project curve, you are going to use this sketch, and object is this one, the green you see, and vector is obviously it has to be this one, x direction. Okay. So now you have copied the sketch onto this one. Okay. So let me just hide this. You right click and you go to hide. Okay. Because I don't want this right now. Okay. So that you don't get confused why there are two sketches. Okay. So now you have basically what happened here. When you do design, right, you will come across small errors or some lag between your softwares. So you have to optimize that also. So we have basically projected the curve, but what happened is this, if you can see, it's not continuous, it's not closed. Okay, so you just have to do a small patchwork there. Okay, so you create a line, okay, and you connect these two. So same, I've just used a line to patchwork. Like now the design is complete. Okay, like you have a closed boundary. Okay, fine. You have a closed boundary. Okay, let me just hide this also. Don't get used. So now you have the sketch onto the part. Right now, what we are going to do is, right. So now I'm just going to. This is just a reference. Okay, if you can see here, okay, the design is basically slightly away from the your base part, right? So what I'm going to do is I've basically got a base surface. Okay. So I'm just going to hide this. Okay. And what I'm going to do is now I have this sketch at a curve, curvature type of profile, right? So now you have to go to, now all I have to do is using these boundaries, there is an option called fill, okay, in surface. So what you do is you go to surface. Okay. So basically all this is surface, right? So whatever you see, your paths, they are termed as surfaces. Okay. They are not paths, they are surfaces. So you go to fill surface. Okay. So for fill surface, what you're going to do is you're just going to select the curves here. Okay. So you're just going to select all the curves that are around here. So once you do that, what happens is you're just going to get a closed profile. Okay. So you can see here. So once I select all the curves, and I'm going to select the curves here also. Okay, just for a good curvature. You can see here. Now it is quite even, right? Fine. So this is your base type of part. Okay, just for a reference. So this is, we have basically created one half of this. Okay, right? So now you have to, now we have this base part, right? So now I talked about, we have to create this one, right? So you have to create this part, this one, right? You have created this one, right? Now you have to create this area here, okay? So the design process is the same, but it is at a distance, right? So if this is at a base, okay, level, and you have between this and this, here you have a small distance, right? So that can be of any mm. Okay? That is how you get the curve profile, right? So let's just design this part, okay? This part little above from the base. So now I'll just keep this aside. I don't want to confuse with the part that we are creating next. So I'm just going to hide it. Okay. And it's the same process of creating the sketch. Okay. So let's just, okay. So again, I'm going to create a curve once again. Okay. So what I'm going to do is just for a easier understanding, I'll just show you. Okay, you can see here, right? So I've basically created the same. Okay? How we had created the first initial sketch, it's the same. I'm just creating it at a distance, lower one. Okay, fine. So now what I'm going to do is I'm going to extrude this. Okay, so we have the base, and I'm just going to use the option here. Okay, like I told you, extrude for converting your line into a part. Right. So now you should understand that it is at a distance. Now you have two sheets. Okay, since we have created a sketch that is below this one, now you have two uh, sheets, right? So now what you do is, okay, so if you see here, okay, at this area, what happened is it is it's basically very close to the part, right? So we don't want that. We want to be little bit, because the part has to be little bit extra on the edges. Okay, we don't want it to exactly end. Okay, because that will basically give you a design error. Okay, so let's just extend it little bit, because anyway we are going to trim the part. Okay, we're going to cut, right? So we just extend little more. Okay, so for extending the part, okay, so you have something called extend sheet. Okay, so that is also available, okay, here in the thing. Okay, so you go to surface again. Okay, you go to extend sheet, right? We had seen about fill surface. There is something called extend sheet, right? So you can use this to use this edge. Okay, this edge and this edge, or these two edges, basically for extending it little. Okay, so let me just see. So we have just extended the sheet. What I've done is I've just used the same option that you see here. Okay, I've extended it. Okay, at, at just 10 mm from its original position. So this one and this one. So both the sides, these two sides. Okay. So I've used two edges. So now you have a little bit more, right? So it is a little bit away from this part, right? So now again, the concept here is you have to start creating. So this is your base, right? So you have to start creating the same shape, and you have to create the same projected curve, right? So what we are going to do is we are just going to use the same. You have projected curve, right? So let me just put this hide it. Okay. So what we are going to do is the same part that was on top, right? So we are going to use the same sketch onto, we projected onto this new sheet that we had created. Okay. So once that is created, now you have this sketch, which is lower to the one that we had created. All right. So again, you go to, what you do is you go to fill surface. Okay. And go to fill surface and just use all the curves that are available here. Okay. The boundary and these two curves. Okay. Now you see here. Okay. Uh, and let me just put on that one that we had created earlier. So can you see? So yeah, can you see? Now we have created basically two sheets. Fine. So one, the lower one, and one on the little above upper one, right? Now you have two sheets. Now we are almost at the end of our design process. Okay, now you have two sheets available. Now what you have to do is just take a look at this profile before we move forward. Just take a minute to understand. Now we have created this sheet that you see here, right? So this part we have created, and this one, right? So similar at a distance. So this is basically the distance between the two sheets, right? So just take a look at this and just give me a minute. Okay. So yes, so coming back now, hope you basically had a good understanding as to what we have done so far. Okay. Now, if you can see, now two sheets are being created, right? So now what we are going to do is we are going to sketch this profile that you see, okay? This one that you see, right? So it has to basically, we have two plain sheets, right? So you have to basically sketch this part, okay, and cut it, right? So you need this, basically you just need only this part, right? So let's just see, okay? So if you can see here, okay, uh, basically this is the sketch, okay? Just so we have used this, you go to sketch, okay? You go to sketch and then use a arc, okay? And you from there to here, you're going to sketch. All you're going to do is you're just going to take a curve, okay? And you can basically do this, okay? I've used a 3-point arc curve, okay, to create this profile, fine? So, so once you have these two sketches, okay, so now this sketch, right, will be used to basically cut the part. We don't say cut in design. We use the word command called trim. Okay, you can see here in your home. Okay, you can see trim body. Fine. Or if you go to surface, you go to trim sheet because this is a sheet. So you are working on surface. Fine. So you go to trim sheet. So trim sheet. So what happens is you're going to select the body. Okay. And what you're going to do is you're going to select these two lines. Okay. So that is going to be used to cut the part. Okay. Let's just see once you execute that command. Okay. So the top sheet that you see, right, we had seen. So that we have used to cut. Okay. You can see here what has happened is we have used this line, right, to cut this part. Fine. Similarly, you have another sheet, right, which was color coded to green, right? So you are going to do the same. Okay. The same sheet. You're going to use this line. Okay. You go to trim sheet. Okay. First you're going to select the first body and this line. And the other one is you're going to select the green, the select second body that we had used. And the line is going to be this one. Fine. So now you can see, right? So let me just put this off, like I can take this hide it, okay, to get a clear view. Just going to hide all the sketches. We don't want any 2D parts right now, right? Now you can see that there are two sheets, basically the two sheets, and we have cut this portion, fine, okay? I'm just rotating it so that you get a better view of it, okay? So can you can you imagine that we have created these two, right? So now if you just look back to this model, so we have this model, we have this, okay, and we have this one because we have basically cut this portion that you see, right, from both the sheets. We have used the trim command to cut it, right? So yeah, now you have to basically join these two, okay, because obviously you cannot have two pieces of one single bonnet, right? So you're just going to join these two. And for that, what you're going to do is you're basically going to go through the option called the through curve option. Okay. So I'll just tell you where that is. you go to your surface, okay, and you can basically use the through curves. So how that works is you have this, right? You have basically you have this profile here, fine. So this is continuous, and you have a profile, this one, which is also continuous, right? So you can use this curve, these two curves, okay, which forms similar to what we had done earlier. Like we basically created through curve two lines to form these two lines, right? Curves to so that we get a even curvature along this, you know, sheet, right? So similarly, we are going to use these two uh, curvature profile, okay, this one and this one to kind of join, okay. So you have the option called through curve, okay. So in the through curve command, you can basically, you see here, right? So this is where the through command is, through curves basically. So using this, you can use see, so what I've talked about. So this, we are going to use this edge and this edge, okay? And we are going to give a continuous profile, okay? Basically, one you have an option called tangent and another one is curvature. So we don't want it to be tangent, okay? Because here, what you can see here is the curve is applied, okay? For an even curvature, we are going to go for G2, okay, that is curvature profile. The first one that you see here is this face, okay, this is the first face, and this is your second face. And the condition is these two edges to be curvature profile, okay. Now you have the bonnet 50% ready. Okay, I'll just tell you 50%, okay, because the design aspect has been done, okay. Uh, if you see, okay, so now you have now three different. Now you have this sheet, you have the through curve. This is also a sheet, right? And this, so now all these three has to be like, you know, joined together. Okay, we are not going to use any welding type of any of the process. It's just going to be one single part. Okay, so for that, you have an option called sew. Okay, so that is nothing but like knitting your clothes that you must have seen in your stitchings, right? So basically joining of two cloth, right? Similarly, you go to sew here, okay? So this is an option in your surface. So this one, this basically makes all the, you know, individual parts as one. Okay, so basically I've just selected this, I've selected this, okay? So it becomes, these three sheets become one, okay? So that is how you join these three, okay, and you have to do the same with all the parts. So once you use this, first time you use the sew command to you join this face, okay, you join this face and this face, and similarly now this becomes one single part, right? Then again you use the same sew command to join this face and this one. So at the end, this becomes one single part, fine. So that is why you can see that it has been done twice. Okay. Uh, so this is whatever we are doing, the options, right? So this will basically be tabulated. So this is like your design tree, whatever we do. It has been, you know, so that you can go back and edit it whenever you want. Okay. So now we have the bonnet. We have designed it using all the commands and, you know, our design knowledge. Fine. So now you basically, like I told you, 50% of the work is done, right? So if you ask me as a designer, right, how can I, you know, we still have this part left. We have only created this half, right? We also have this part to be done. So here, here is where the software basically helps us, right? So if you see, these two parts are basically symmetry. Okay, they are equal. Okay, So you have an option called mirror geometry. Okay. So what you can do is you can just copy, okay, whatever here. Okay. Again, you're just going to use this plane. Okay. You can basically go to mirror geometry. Okay. That is nothing but it's like copying this onto the other side, just a plane in between. Okay. So you can basically see it from here. Okay. So you can go to mirror. Okay. So you have the mirror feature here. Okay. So again, it says associate copy. So you're just copying this, whatever we have done. Okay. Onto the other side. So you go to mirror geometry. Okay. And once you have that, okay. So once you go to mirror geometry, you're going to select the part that we had created and we need a plane. Okay. So plane at which it has to be copied. Okay. It's like a mirror. Okay. So you stand in front of a mirror. What happens is your reflection is on the other side, right? Between two images, you have the mirror in between. So it's the same concept here. You have the part here, and this becomes your mirror, and you have the reflection. Right? So now by using this command, what I have done is whatever we have done so far, we have just because it is symmetry, we can easily, you know, complete the part. Fine. So this is how you basically you create the a part that is the bonnet, the basic out structure of the part that you see here. Okay, the curves might slightly differ, basically. So you can work on it, right? Now, basically all you have to do is you just have to increase the uh, length of the sheet, okay? And the curves can also be, we had seen about the curves, right? You can also edit the curves for a better curvature that you see. Okay, so yeah, so this is how. So we have basically created the bonnet aesthetic, okay, from the design sketch that was given. So, so this is possible using your CAD software, right? So I hope so I hope everyone were kind of able to understand what is possible. Okay, the end goal here is not to start just just right away start designing it. Okay, because if you have a design knowledge, if you already have worked on parts like design softwares, then it will be a little bit easy for you to kind of understand the commands. Okay, so here our goal is not to just replicate the design, but to understand the design aspect, right? The design possibility and the design process using the NX cache. So that is what the workshop is. You had basically. I hope you all learned something from this one. So that's all from my side. Thank you all for learning. And over to Ashish. If you want to conclude, you can take the floor. Yeah.
Hello. So, am I audible to everyone?
Yes, sir. You're audible.
So, I guess the session was very informative, and every one of you must have gotten to learn a lot of things as well. So, is there any questions that we have? Any questions?
So yeah, I think there are a few questions in the chat box.
So I think there's a question which says which is the most preferred software in the industry.
Okay, so to answer that, preferred software for designing is basically same like NXCAD, SolidWorks, and CATIA. It basically it differs from industry to industry. Now, if you take an automobile industry, they go extensively with CATIA and maybe for manufacturing NX. So these three softwares are very common. There are other small softwares that are also used for designing, but these three are common to across automotive, aerospace, and rail that you see. So yeah.
So I see more people's getting interested in sessions like this rather than questions. You can see that a lot of people are saying that we would be happy if there are more sessions like this.
Yes. So yeah, good to know that many have grasped the concept of designing.
Yeah, definitely. Okay, so before winding this up, I would like to let everyone know about obviously the workshop. I am pretty sure it was very good, which is why we could see the kind of response we are seeing. So before winding this up, let me tell you that the major reason for why we are conducting these workshops are to let you know that yeah, these workshops are just a part of what exactly we are doing at IIT Kanpur. So we are actually providing certification and professional or job leading courses, which you can either ways you can call them. We are providing these courses at IIT Kanpur directly. So these courses, as I say, certification courses are where you actually get to learn about UGNX. In brief, these are just basic details, or you can say some knowledges over UGNX that you gain today. But we get to see a lot of things where you actually get to know in brief about UGNX as well in the sessions. Can someone has just turned a whiteboard? Can you just put it off? Yeah, thank you. So these are the courses where you actually get to know about QGNX in brief. So this was just a basic session where you got a little idea about the car bonnet design using UGNX, and I'm pretty sure you'll get to know a lot in the certification courses. So these certification courses are in a certain durations which are very less. You can say in 1 month, 2 months duration, where you get to learn about UGNX and you get certified by IIT Kanpur for it as well. And when I talk about job leading courses, we actually have courses, named as vehicle design and analysis, where you get to learn about multiple softwares. I could see a lot of people talking about SolidWorks and UGNX both at the same time. To give you an idea, we actually have a course called vehicle design and analysis, where we actually get four softwares at the same time, which is CATIA, SolidWorks, UGNX, and ANSYS. So you get to learn all these softwares in one particular course, and the duration of the course is around 7 months, right? So we have these courses where you can actually go learn all these softwares in a smoother way from the industrial experts. And in these courses, we also provide you placement support as well, right? So when we talk about placement support, we give you guaranteed interviews wherein you are trained for those interviews. We take your mock interviews, we do your skill training, and all these things are done before you are sent for any interviews to the industry, right? So all these things are done where when you visit the site, you'll actually get a lot of details about it. I'm just pasting the last link of the site. I think everybody has got it in the chat. If you go to this website and if you see the online courses session, you will be able to find out the courses which are related to UGNX, and you'll get all the details over there, including the curriculum, the profile of the trainers, the course fee structures, and all the other details related to the course. I mean, the industry demands, what we are providing, the industry projects, the timings of the classes, everything you'll be finding here in this particular website. When you go there, You find all the details, and obviously whatever individual doubts you have related to the course, we will be reaching out to you individually to clear it out as well. We'll be reaching out to you very soon, right? But yeah, for all the details related to the courses of UGNX, you can actually go to the site, and you will be able to find all the concerned doubts that you have. You will be clarified once you go and visit this site. Right. So the certification will directly be from IIT. To give you a clarity on that, it will be directly from IIT, also accredited by MITI as well, Ministry of Electronics and Information Technology. Right. So you'll get both the accreditations on the certification. And to give you more clarity, this is a global certificate as well. So this certificate not only gets recognized in India, but in other countries as well. So people have gone use this certification in for higher studies in other countries as well, and for jobs in other countries as well. So that is the value that the certification holds, right? So you get a lot of facilities such as industrial insights. You get training from the industry experts, and it's a very good way to put up to get a big hold in the industrial field. These courses. Yeah. So I think you guys can visit this site to get all the details. What I explained. And talking about the certificates, you will definitely be getting the certificates to your mail ID, to your registered mail ID by 12 p.m. tomorrow. So by 12 p.m. tomorrow, you will be getting all the all the details of the certificates. You'll be getting it over your mail. And if there is someone who is not getting the certificate over mail by 12 p.m. tomorrow, I'm pasting a mail ID where you can actually raise your queries with your details. So this is the mail ID. I've pasted it. If anyone is not receiving the certificate by tomorrow 12 p.m., do let us know through this mail ID with all your details, like your number, your name, and all your details. Right. So thank you everyone for joining today's session. And as we could see that a lot of people were interested for this, like for more sessions like this. So we assure you that we'll come up with more, such informative sessions, not only about the design field, but for other fields as well. We'll definitely come up with more interesting sessions where you'll get to know about the industry, get to know more about these fields, and you can have a good hold in the industry after learning about this as well. Right. Thank you, everyone. As I said, the certificates will come to you via mail. And for all the other related information about the course, you can visit the site ifacet.iitk.ac.in. I've pasted it in the chat as well. Right. See you soon, guys, with other informative sessions and workshops. Till then, have a great day, everyone. Thank you.